Okay, so section 9.8, which is the Pythagorean theorem and space figures. We are going to be talking about three-dimensional shapes. The first one we're going to be referring to is called a rectangular solid. So a rectangular solid has 6 faces. You can see the face colored in blue. So that's 1, and then there's another face over here on the side, that's 2. Think of a Kleenex box, the top and the bottom, 3, 4, and then the back and the left side as well. So there's 6 faces, as well as 12 edges. So we refer to the edges that are on the ends of the faces. So you can see I colored that one pink. From H to G is another edge. Okay, from F to B is another edge. From G to C, those are all what we call edges. And then we have some diagonals. So when we're talking about the diagonals, we're talking about the diagonals of the solid. So HB is a diagonal. So picture from H to B, picture from C to E, again going through, from G to A, and from D to F. So we call those diagonals. We're also going to be talking about a regular square pyramid. Again, we only have one base in this. The base is JKMO. You can see that's the bottom, that's the base of this. That's what we refer to this as. You have the vertex, which is right up here, the tippy top of the pyramid. You have the altitude, which is in blue. That is the straight up and down height of the pyramid. I refer to that as PR. And then you also have something called the slant height. And again, that's the height of this on a slant. So when I'm talking about these shapes, this is what I'm actually going to be referring to. So the first problem we're going to be talking about here, we are going to find the diagonal, and the diagonal is HB. HB. So we are going to find that diagonal of HB. So things that I know about this, because this is a rectangular solid, look at these edges. So I'm going to color this edge pink. Any of these pink edges that we are referring to are 7. Okay, you have this 7 right here. Any of the blue edges that we are referring to are 3. And you can see that the height, which is also this edge, is going to be 5. Okay, so I'm looking at some of these things. I also see that this is a rectangular solid. And the important thing about here is you can see these little right angle marks built into this. And so I am going to start for HB, I'm going to start by pulling out this right triangle that HB is contained in, and I'm going to put the points. So look at how important this is. So HB is this diagonal right here. So I'm going to start, let me erase all this, okay? I'm going to start by pulling out this triangle right here. This is what I'm referring to. And my third point would be D right here in this corner. Now, of course, I know that the height of this rectangular prism is 5. Therefore, from H to D is also going to be 5. So I can put that in here. However, I don't have from D to B. I don't know this length right here, but I can find it. And I can find it by using this right triangle right here. So again, spatial recognition. I'm going to pull out this right triangle, and again, I'm redrawing mine. I like to redraw it. So this is D, A, and B, and the right angle is right there. I know from A to B is 7, and from D to A is 3. So this is not a triple, but we can do Pythagorean's theorem. So 3 squared plus 7 squared is equal to dB squared. So add those together, you get 58. And so therefore this is the square root of 58. I just like to kind of go through fast with this. So we have dB to be the square root of 58. Now once again, this dB is the same as this dB, so I can put this in as the square root of 58. And now to find HB, I have 2 sides, and I can use Pythagorean's theorem again. So, and again, I like you guys to get in the habit of doing this in your head. So the green side squared plus the pink side squared has to equal that HB squared, and 25 and 58 gives me 83, and I take the square root of it. So from H to B is the square root of 83. Now again, if you'd like to write the Pythagorean theorem out, 3 squared plus 7 squared is equal to DB squared, you absolutely can. This one would be 5 squared plus the square root of 58 squared is equal to HB squared. And again, you can show all your work if you'd like to. You'll get the same answer as I did. I just like you guys to practice using this in your head. Example 2. With this one, we're going to find a bunch of different things. So they're giving me that the base perimeter. So this is a square pyramid, and that's important because it's a square on the bottom. So we have some right angles in each of these corners. There are right angles, and we have congruent sides. They also tell us that the perimeter of the square is 40. So immediately I'm just going to fill in that we know that these sides are 10. So this is 10, this is 10, this back is 10, and this side over here is 10. And they also give me that from P to K is 13. Okay, so I'm going to erase that 10 and that 10 really quick. And from P to K, I'm going to highlight. Okay, and highlighters are great here because then I know that I'm referring to this pink side, and that pink side is 13. I also have these blue sides. Any side that is blue is going to be representing 10. And so again, it's just easier for me to see that that represents 10. So we are going to start, it tells us to start by finding JK, so obviously JK is 10. Our next question says to find PS. So PS is representing that slant height. And so we need to kind of pull out a right triangle that we can use with that slant height. Okay, so I know that we have, let's see here, we have our 10, and we have, oh, from the center, okay, so we have R, which is in the center. I got stumped for a second. So from R to S, that is going to be 5. We know from S to K that is also going to be 5. This is going to be 5. So we have this information. So if it's asking us from P to S, and I know that the, let's see, that is 13. Okay, I'm going to pull out this triangle right here. So sometimes it takes a second for me to find the triangles, but I'm actually going to pull out this one. Okay, and again, you guys can see that right angle that's in here on this side. There's another right angle right here on this side. So I'm going to redraw this, and I'm going to draw it this way for you guys to see. So the P is obviously at the top, and here's the S, and here's the K, and here's your right angle. And I know that SK is 5. Okay, I know that SK is 5. I know that they gave me PK. Oh yes, here we go. They gave me PK is 13. And so therefore PS has to be 12. Okay. So we have our PS of 12. And again, just using those colors, sometimes these numbers get so mixed in here, but the PS is 12. The altitude, so they want us to now find PR. Okay, so I already have my numbers in there. Oh, cool. Okay, so I'm going to erase this orange triangle that I took, and I'm going to pull out this green triangle. And again, it's hard because this is inside the triangle, inside the pyramid, I should say. So it's hard sometimes for us to kind of visualize this, which is why I like to draw them out flat. So I'm pulling out this triangle right here. This is P, R, S, and we have our right angle at the bottom. We know that from R to S is 5 because it goes from the center, okay? The slant height of a regular square pyramid goes from the center out. The center is obviously half of 10, so I know that's 5. I just found that PS right here, this PS is 12, and they're asking me to find this value right here. So once again, we are going to do Pythagorean's theorem. So 12 squared is equal to x squared plus 5 squared. And because I'm looking for a leg, I subtract these. 144 minus 24 is 120, but I'm not taking away 24, I'm taking away 25. So that means this is going to be 119, and then we take the square root of it. So PR is going to be the square root of 119. Once again, with these three-dimensional shapes, and I have some review down here, but with these three-dimensional shapes, it's really important that you pull out the triangles that you're working with, use highlighters, use colors, put your right angles in there, and to me, that just makes all the difference as to what you're going to be working with, okay? As a couple reminders, on your speed quizzes, these are the triples that you guys should have memorized. You should be able to take a look at the 45, 45, 90 and 30, 60, 90 and really understand where these numbers are coming from. And just remember, when you're doing Pythagorean's theorem, you should never be working with numbers this large. I wouldn't even work with 2 and 4. I would divide those each by 2. So this is a 2 and this is a 1. And then go ahead and do Pythagorean's theorem. 1 squared plus 2 squared equals x squared. Okay, you should be able to do this in your head. So this is the square root of 5, but don't forget, we divided by 2, so multiply by 2, and we took off 2 zeros. So the answer is 200 root 5. So really just getting in the habit of trying to do that Pythagorean theorem nice and fast in your head. 30, 60, 90, same thing. Really trying to use that shortcut, and 45, 45, 90s, and of course triples. So these are all fast ways that you can get in the habit of working with right triangles.